The first thing we're going to do is talk about cupped up and cupped down parabolas. Those are the functions. There are other kinds of parabolas, but cupped up parabolas are what we're talking about today. So, I'm going to be drawing the parts of a typical cupped up quadratic function of the graph. Okay, the first thing I want to do is draw something called an axis of symmetry. And we could make it through -7. Why? Why -7? I have no idea. Just occurred to me. I am not making a special parabola in any way. It is just a cupped up parabola. So the first thing I do, and I will write this. No, I decided on -8, didn't I? Okay. The equation of the axis of symmetry is x equals -8. Because it's a vertical line going through, x equals -8. Okay, now I am going to choose a vertex. The vertex is always on the axis of symmetry. But first, let me write the words axis of symmetry. A-X-I-S of symmetry. S-Y-M-M-E-T-R-Y. Axis of symmetry. Symmetry means balanced, and in a properly drawn quadratic function, the parabola will be centered. All the points on the parabola, left and right, will be equally distant from the axis of symmetry. I'm going to try to draw something like that. Okay, we'll see if I can actually do it. I'm going to pick this as the vertex, okay? So this is located at, let's see, this is -8, -9, -10, -11, -12. This is -10 on the y-axis. And -8 on the x-axis, so this point is -8, -10. All right, now, I am going to draw some points. Okay, this is going to be a very simplistic parabola. They have to be equally balanced around the axis of symmetry. Got to make it curve up. It's not a straight line. Okay. And let's see, let's make it go here. And make it go, let's see, 1, 2, 3. Okay, 1, 2, 3. And 1 over? Yeah, That's what I did. See, it has to be exact, and it automatically will be if anybody besides me draws it. Okay, now, very important to remember that parabolas do not come to a sharp V. Okay, so if this is the x-intercept here, then this will be the x-intercept here. Now let's see where this goes. Okay. Now this is 6 on the x-axis, y-axis, 6 on the y-axis. So, and it is 1, 2, 3, 4, 5, 6, 7, 8 units to the right. So over here, 1, 2, 3, 4, 5, 6, 7, 8 units to the left, I will also have a point because you always have exact symmetry around the axis of symmetry. Okay, now after I do this, I can relax a little bit and make it sloppy. That is my parabola. This is not a sharp point. Absolute value functions come to a sharp point. Parabolas, quadratic functions never do. So when you graph these, you have to, on paper, you have to make sure that it's very clear that this is curved and not a sharp point. Okay, so this point right here is called the vertex. I'm going to make it in red because it's on the axis of symmetry. Always. You can count on it. Right there. Now you have an x-intercept at x equals -2 and an x-intercept at -14. And you have a y-intercept. Now, I don't know if this is even a possible thing that I have graphed. But it doesn't matter because this is just to illustrate an idea. 0, 6, or 6 on the y-axis is the y-intercept. So let's write all this down. Okay, this point is -2, 0. -2, 0 is an x-intercept. -14, 0 is an -14, 0 is an x-intercept. The vertex is -8, -10, and the axis of symmetry is x equals -8. And what I've done is what my math lab refers to as labeling the parts of a parabola. Okay, I labeled them, but I'm actually going to write them out. Okay, the vertex The vertex is the point -8, -10. The x-intercepts are located at, well, are the points -14, 0, and -2, 0. I'm going to skip a space because I'm going to write something in here. The y-intercept is 0, 6. And the axis of symmetry is a line and its equation is x equals -8, which is a very typical way to write the equation of a vertical line. It's always x equals a number. Well, this is x equals the number on the x-axis that the axis of symmetry goes through. And that's how you construct a vertical parabola or a cupped up parabola. Now there's another fact, there are a couple of other facts you need to know. For instance, the zeros of the function the zeros of f of x are -14 and -2. The x-coordinates of the x-intercepts are called the zeros of the function. Now, there's another, let's leave it there, but it is a little more complicated and we'll talk about it. Okay, these are the very important parts of a quadratic function. Is it cupped up or cupped down? What is the vertex? What is the axis of symmetry? There will always be one for a quadratic function. What are the x-intercepts? There won't always be x-intercepts, but there will always be a y-intercept. And again, we're talking about functions. We're not talking about the sideways kinds of parabolas. They're not functions. We're just dealing with functions. Okay, now we're going to talk more about the vertex of a cupped up parabola. This vertex is -8, -10, but it's more than that. The vertex is historically one of the most, the most important part of a parabola because it has economic consequences and economic meaning, a meaning in economics. If you go into business, you'll learn about it. But it's so important, we call it HK. That is, H is the X coordinate and K is the Y coordinate. But the vertex is so special, it gets special letters. Now this is very, very important for a cupped up parabola. K, the Y coordinate, is called the minimum value of the function. It's the lowest y number reached by the graph or by the function. The very lowest number. All of the other f of x numbers will be higher, but this is the very lowest. So k in this instance is called, actually, did I say maximum? I meant minimum if I didn't say minimum. X is called the minimum value. Okay, K is called the minimum value. So in this problem, -10 is the minimum value, of f of x. H, in a way, is even more important because H is considered to be the physical location of the vertex, of the, not the vertex, of the minimum value. So the kind of statement you're going to see as you do your homework is the minimum value -10 is located at -2. You don't even have to say x equals -2 because locations are always on the x-axis. Okay, now there's one other generality for cupped up parabolas and for cupped up down parabolas. All of these will have counterparts. No, there is more to talk about. Um, um, um. You've done transformations now. There is a transformation equation so that the parabola can be moved all over. Transformation equation, or I guess it would be better to say formula. But I've only heard transformation equation. F of x equals a parentheses x minus h squared plus k, where k is the vertical shift, h is the horizontal shift, and a is the number in front, which, for cupped up parabolas, this number will always be positive. And you know that from transformations, because when that number is negative, you have reflection across the x-axis. It's turned upside down. And that's what we're going to do next. But what I want you to notice right now is that there is no graph down here at all, is there? There's no graph. It's like a vacuum. Nothing is happening below the vertex. Nothing is happening below the vertex. The vertex is the very lowest point, and the graph goes up in both directions from that point right there. As a result, the range of a cupped up parabola will always go from, remember the range is on the y-axis, for a cupped up parabola, which is what we're talking about on this page, the range will always start at the k value with a bracket and then go up, up, up forever. Meanwhile, the domain of all function parabolas, no, not now. The domain of all the function parabolas is always negative infinity to positive infinity. And something else is going to always be true for cupped up parabolas. This side will always be coming down from the left. This side is called the decreasing side. And this side is called the increasing side. Let me find a place closer there. Increasing. I cannot do this. Try though. Increasing. Whew. Because it's going up from left to right. As you look from left to right, the right side of the parabola is going up, the left side of the parabola is coming down. Even though we customarily write with arrows like this, when we talk about increasing and decreasing, if something is dropping from left to right, it's decreasing. If something is rising from left to right, it's increasing. We write the intervals of increase and decrease this way. Parabola, the parabola. Is increasing on the interval. That's how you say it, on the interval. -8. This is where the increase starts. -8 and up forever. We never use, when we're talking about increasing and decreasing, we don't use brackets. Not on a continuous curve. The parabola is decreasing on the interval negative infinity to negative 8. Now notice that we're talking about intervals on the x-axis because we're talking about location. Where is the decrease happening? Where is the increase happening? So from negative infinity out here, all the way into negative 8, the parabola is decreasing. From negative 8 all the way out to positive infinity, the parabola is increasing. So for this problem, the range would be negative 10 to infinity. Oh, I put negative 8. I actually did put the numbers here, but I need to give you the formula numbers and then I'll write, well, how can I do this? Let's do it this way. Cupped up parabolas. Cupped up parabolas. Increase on h to infinity. Cupped up parabolas decrease on negative infinity to h. Okay. How was that? Let's go over it because then we're going to go over the same thing for cup down parabolas, only things will be different. Well, it's going to be a different parabola also. Okay, your important parts of a parabola, your most important parts are the axis of symmetry, the vertex, the x-intercepts, the zeros, and the y-intercept. You're about to learn that a polynomial, which is what a quadratic equation is, a quadratic function, they're determined by their zeros. They're created from their zeros. So the zeros are very important. The zeros are the x-intercepts, the x coordinates of the x-intercepts. And then the y-intercept. The vertex is so important because it tells you so much other stuff. Like what's the minimum point, what's the minimum value, where's the minimum value located.
I have a question.
Yes.
You have the minimum value negative 10 stated at it's located at negative 2. Is it not located at negative 8?
Yes, it is. Why did I do that? Oh, I must have been looking at negative 8. Yes, write negative 8. Damn, I hate it when I do that. Darn, I hate it when I do that. Negative 8. Definitely. And I did keep it negative 8 for the rest of it. Good. Yes, the minimum value is negative 10. The minimum value or the maximum value is always on the y-axis. It's part of the range. but the location is always on the x-axis, and that would be -8. Okay, so you have the domain is always going to be -infinity to +infinity on the x-axis. That's where the domain is. The range will always, for a cupped up parabola, will always start at the lowest y value and go up forever. That's what cupped up parabolas do. Now for cupped down parabolas, we have pretty much the same kind of setup. We could have, now let's do this. Maybe we can do this in a little less time-consuming way. If I make this the vertex, and I make this the y-intercept, this is going to be the axis of symmetry. There's no way it can't be because the axis of symmetry always goes through the vertex. All quadratic functions cupped up or cupped down will have a vertex, period. They won't all have x-intercepts, but I'm just drawing all the points right now. Okay, now this is located 1, 2, 3, I should start there. 1, 2, 3, 4, 5, 6, 7, 8 units away from the axis of symmetry. So 1, 2, 3, 4, 5, 6, 7, 8. This will be a point on the parabola. So let's do this before we do anything else. Not great, but okay. That's my very bad cup down parabola, but it will have to do. Parabolas are cupped down with when the number in front, the leading coefficient, A, is negative. Any number less than 0 is negative. Okay. Let's see, what else did I put up here? Yeah. All right. This is the axis of symmetry. And its equation this time is x equals 8. Yes, and so the point, the HK, will be the point 8, 12. Okay, the way I've drawn this, again, I don't know if it's even possible. The way I've drawn this, that 0, 1 is the y-intercept. And the x-intercepts, the way I've drawn it, are located at 17, 0, and negative 1, 0. Which makes the zeros of the function negative 1 and 17. So I'm going to start writing all this down now. Okay, the vertex is 812. So H is 8 and K is 12. And so I actually didn't write the transformation equation before, and I could have. What bothered me is that to make this even remotely possible, I have to know what the number A is, and I don't. So what can I say? I'm just going to pretend it's negative 1 and pretend that's possible. So the transformation equation is f of x equals negative x minus h plus k. Now let me write, squared. The formula for this is f of x equals a times x minus h squared plus k. That's the transformation equation. So you see, if you were going to write, how did that get here from the basic y equals x squared function, you would say it is shifted 8 units to the right, 12 units up, and then flipped upside down, otherwise called a reflection across the x-axis, um, uh, by negative 1 in front. Okay, now let's look at this. The domain is always going to be, oh wait, I haven't finished talking about the vertex stuff. There's vertex stuff and then other stuff. Okay, the maximum value now, because that's the highest point reached by the graph. There is nothing up here, it's like a vacuum. The maximum value is 12. Located at eight. Okay. The domain is negative infinity to positive infinity. Because all of the x values on the x-axis will ultimately be used. The range, though, we would normally think of it, but I'm going to erase this. We would normally think of the range as being from k to negative infinity. That's the way we would think of it, but it's not the way it's written in math. So let me do this the correct way. We always put the lowest number first, and that would mean negative infinity goes on the left. Oh, no. Let me show you before I write it. The way range is thought of is going from down here at negative infinity all the way up to 12, right? That's the highest y value. So from negative infinity all the way up to 12 with a bracket. Now notice this, that with a cup down parabola, this side is now the increasing side. And now this side is coming down. This is the decreasing side. Again, I know I've said this before, but trying to write sideways with a tablet is really hard. A piece of paper you can just turn around, but it's not the same thing with a tablet. Okay, let me save what I've done here. Okay, now the interval of increase is going to be from negative infinity into positive 8. Negative infinity to 8, and we always use the x-axis as the location, and we never ever write brackets when we're talking about increase and decrease. There's a reason. If we did that, then the vertex, well, 8 would be, you'd have to decide, is it still increasing at 8 or does it start decreasing? It can't be both. What is it? So the way we handle it is we just use parentheses. Over here, the interval of decrease is the interval of decrease. Ow. How do I turn it off? Go away. Okay, where was I? Yes, okay. The interval of decrease starts at 8 and goes to positive infinity. The interval of decrease goes from 8 to infinity. Now, the x-intercepts, I'm sure I'll think of something I forgot to write, and then I'll just go back. The x-intercepts are negative 1, 0. No, yeah, negative 1, 0. And 17, 0. The zeros of f of x are negative 1 and 17. And the y-intercept is 0, 1.
I have a quick question.
Yes.
When you're writing the zeros of f of x, does it matter which number goes first?
No. Though it is better, you want to keep straight in your head since most quadratic functions have two x-intercepts. You want to keep straight in your mind which one is on the left and which one is on the right for when you're graphing. But no, it doesn't really matter what the order is. Okay?
Yes, ma'am. Thank you.
You're welcome. More questions at this point? Okay. Now, until I can think of something I left off, can you think of anything I left off this that I put on here? Yes. Oh, no. No, I did it. This right here. Okay. So now we're going to actually start doing some math and get away from all this theory stuff. The first thing we're going to concentrate on is finding x-intercepts if they exist. And I seem to have skipped a page, but that's okay. Let's go down to this one. This is a quadratic equation. Notice there's no f of x in it. However, once I subtract 15 from both sides, I will have this in the correct form. Here's the correct form. I'll have 4x squared. Is that big enough, or do I need to write it bigger? Would it be better?
That's better for me.
Good. Very good. Thank you. I do need feedback because I cannot read minds. Okay, so this will be 4x squared plus 4x minus 15 equals 0. Now this is factorable. I can solve that equation by factoring if I use the AC method. So let's do that just for review. A is 4, B is 4, C is negative 15. To use the AC method, I multiply the number A times the number C. That will give me 4 times negative 15, which is negative 60. Now, I need two factors of negative 60. That add up to B, which here is 4. So I have to take negative 60 apart. When a number is negative, I think about the positive first. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12. Yes, 5 times 12. 6 times 10. And then they start repeating. Okay, but, this is a negative number, negative 60. And that means since negative times positive is negative, I should make one of these coordinates negative. Negative 6 times positive 10 is negative 60. Oh golly. Negative 6 plus positive 10 is 4. Bingo! These are our numbers. So here's what I'm going to do. I'm going to go back up here, take 4x squared plus 4x minus 15 equals 0. But 4x is going to split apart into two terms. 4x squared minus 15. Don't really need that much room. Okay, 4x is going to split apart into two terms that if you add them together, they equal 4x. But they have to multiply together to equal a times c, and we now have those numbers. We have negative 6, which I will turn into minus 6x, and positive 10x, or positive 10, which I will turn into plus 10x. And now using the AC method, I will group and I will group. So I'll take a GCF, a greatest common factor, out of both sets of parentheses. 2x, 2 goes into 4 and 6, and x goes into x squared and x. So 2x is my GCF. That'll be 2x minus 3 plus, keep your plus. 5 will go into 10 and 5 will go into 15. So 5 will be F, and that will give me 2x minus 3. And don't forget your equals 0, but I'm still factoring. Now 2 minus x occurs on both sides of the plus sign, so it becomes the GCF. 2x minus 3 times the leftovers, that's what I call them, the leftovers, 2x plus 5. Now that's the factorization, but recall that when you solve a quadratic equation, you have to go beyond just factoring to setting each equal to 0. Okay, I'll add 3 to both sides. Oh, I might as well just stick to writing on the lines. Plus 3 plus 3. Negative 3 plus 3 is 0, so I'm left with 2x on the left, 3 on the right. I'll divide both sides by 2 in order to solve for x, so x equals 3 over 2. Now come over here. I subtract 5 from both sides. 5 minus 5 is 0. That leaves me with 2x over here equals negative 5. Okay, the solutions of the equation are 3 over 2 and negative 5 over 2. So the solutions of this equation you don't have to put them in order, but if you were going to put them in order, this would be on the left. And this would be on the right, but you don't have to do it that way. I just wanted to show you if you did. They are the zeros of f of x. Well, where is f of x? I didn't write it as f of x. This part right here, is f of x. All right, so these guys, negative 5 over 2 and 3/2, 3 over 2, are the zeros of f of x equals 4x squared plus 4x minus 15. The x-intercepts are negative 5 over 2, comma 0, and 3/2, so 3 over 2, comma 0. See, that's the way it works. Now, it is true that we have not thoroughly analyzed this because all they're asking for are the solutions to this, which are just this. So these would be your answers. But what about all the other stuff? What's H? What's K? What's Y? Well, let's do it. We're just going to do this today. We're putting 7.4 and 7.5 together. We're going to have to do it again on Monday, okay? But let's finish this out. If you are being asked to find the vertex, then you would have to find H, and you would need a formula for H. H equals negative B over 2A. So you have to look up here and see that A is 4 and B is 4. So H will be the number negative 4 over 2 times A, which is 4. The negative sign comes from there. 4 is positive. Both of these 4s are positive. So that's how the negative got there. It's part of the formula. So this will be -4 over +8, which is -1/2. K is going to be what you get when you take your h and put it in for every x in f of x. You can do this in your calculator, or you can just say, well, 1/2 times 1/2 is 1/4.
Isn't it, shouldn't it be
Negative
negative
1/2.
half all the way across though?
Yes, it should. -1/2. It's a negative number. Still, thank goodness that's 1/4. -1/2 times -1/2 is +1/4. But +4 times -1/2 is going to be -2 minus 15. So we will have 4 times 1/4 is 1, minus 2, minus 15. That'll be 1 minus 2 is -1, minus 15, which is -16. Do you agree? I agree. Yes, I do, completely.
Okay, I get it.
Yeah, good. So now the vertex which is the point HK, will be -1/2, -16. The axis of symmetry, and I forgot to put this formula on the first 2 pages, the axis of symmetry will always, if it's a function, have the equation x equals h. Well, h is -1/2. So our axis of symmetry for this problem is x equals -1/2. Now, is this a cupped up or a cupped down parabola? You have to know that before you answer the rest. Well, it's cupped up because 4 is positive. So it's going to be cupped up like that. It's a cupped up parabola, so the vertex is a minimum point. Therefore, the minimum value of f of x equals 4x squared plus 4x minus 15 is -16. Your k. Located at h, which is -1/2. This is h. This is k. What else can we answer? Well, we can come up with the transformation equation. f of x equals a times x minus h squared plus k. Okay, so our a is 4. F of x equals 4, parentheses, x minus, the minus has to be there, your h is negative 1/2, the square is on the outside of the parentheses, plus k, which is negative 16. So f of x equals 4, parentheses, negative negative is plus, so you'll have x plus 1/2 squared minus 16. And that's your transformation equation. And through all that, I left off the y-intercept. It's easy to forget that because it's not really emphasized in anything you're learning right now. But to business, the y-intercept is very important. Also in science. So we'll have to pay more attention to it. But right now, let's just find it. F of x equals 4x squared plus 4x minus 15. The y-intercept is always f of 0. That is, you let all the x's equal 0, and that gives you what y is. So f of 0 equals f times 0 squared. We're kind of winking at that. Just be aware if you take calculus, they'll tell you that that's something special. But it comes out to 0, so don't worry about it. Plus 4 times 0 minus 15. That'll be, this zero's out, negative 15. So f of 0 equals negative 15, which means you have the point 0, negative 15. That is your y-intercept. And we've run out of room and run out of time almost. We could do more. We could do the intervals of increase and decrease, but I don't see any reason to right now, right here. We have found a whole lot of information, and this shows you how to find information. Is that the way you always do it? No, 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 no. Starting on Monday, and this is so important, I don't mind spending all of next week on it if I have to. Probably will. What I want to do is, yes, oh, that's nasty. Yes. Starting Monday, we're going to do this. F of x equals x squared plus 5x minus 7. This is not factorable. It does have a vertex, so we can answer all the vertex-related questions, like axis of symmetry, um, uh, domain, range, intervals of increase and decrease. We can do all that. But we have to do something special to find the x-intercepts because we cannot factor. We're going to be using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, people pay me to not sing. I wonder why. A equals 1, B equals 5, C equals -7. We're going to put it in there. What we're going to find is the zeros of the function. Then, if they're real numbers and not complex numbers, because you can get complex numbers, if there are numbers in the real number system, we can make x-intercepts, even if they're really, really ugly. And I want to write down right now what the zeros are. The zeros are, this is so we can check ourselves on Monday. -5 plus or minus the square root of 53 over 2. That's a way to condense the answers. As you can see, you've got 2 answers here. That's the plus answer and that's the minus answer. I was taught you always put the minus answer on the left. But we'll talk about that on Monday. And we'll start here. So please remind me of that. And do as much of the homework as you can. If you remember working with the quadratic formula, do that. I will have to change the schedule around somewhat, but it'll be okay, I think. Won't be the end of the world. And I'll have to remember this can take a whole week when you've got a 2-day-a-week class. I've got a 4-day-a-week class. We could cover this easy because we've got 4 whole days in a week, but not in this class. So I will see you Monday when we will delve into, we will plunge into finding the zeros of function with the quadratic formula. Bye for now. I'm going to be ending this and you can stick around if you have questions.
Thank you.
Thank you. Well, I need to stop sharing and stop recording.